Let's move on to solving system of linear equation using Cramer's method or Cramer's rule. So to first use the Cramer's method or Cramer's rule, we have to represent what has been given as ax is equal to b. So let's go ahead. So what will be our a? A will be coefficient of what is in the questions. With coefficient, when you take the first equation, we have 1 in front of x1. So the coefficient of x1 is 1. Then over here, it's negative 3. So that those are the coefficients. They represent it in the form of matrix. So you have 1, negative 3. Over here, we have 3 and 2. 3 and 2. We represent it as a matrix. Yeah. Then we take x. What is x? X is all the unknown variables in the equation. So unknown variables will be x1, x2, x1, x2. So you just write x1, x2. We repeat the equal to sign. Yeah. Then write our b. What is b? B is the elements on the right hand side, representing them as a matrix. So the elements on the right hand side are the elements after the equal to sign. So if here was 0, and let's say we had negative 12 here. So let's say if this was 3x1 plus 2x2, then this was negative 12, then we had 0. We have to bring the negative 12 to this side so that all constants will be on the right hand side. Yeah, so we write it as 3x1 plus 2x2 is equal to 12. Then we get this. Yeah. So that was by the way. So over here the elements on the right hand side is 10 and 12. Yeah. So with Cramer's rule, let's first know A. So A, as you said, will be equal to this 1 negative 3, 3, 2. And our x will be equal to x1, x2. Then our b will be equal to 10 and 12. So with Cramer's rule, we first identify the number of columns we have in A. So A has two columns, column 1, column 2. Yeah. Then replace, if there are two columns, we replace the first column with the elements of B. Then we replace the second column with elements of B. Yeah. So let's go ahead to understand. So we have, let's say, our A. We are finding A1. A1 will be A1 will be replacing the first row with this, which will be 10 and 12. So we have replaced 1 and 3 with B, which is 10 and 12. Then we keep the one we did not replace. It will be negative 3, 2. Yeah. Then let's say we have another one, A2. So what will be A2? A2, since we replace the first row with this, we take this one and replace the second row with this to get A2. So with A2, we have 1 and 3, 1 and 3. And this time we replace negative 3 and 2 with 10 and 12. So 10 and 12. Now, after that, we go ahead and find the determinant of A1 and A12. So this is our A1 and A2. Then we go ahead to find the determinant of A1 and A2. So determinant is the product of the 2 by 2 matrix is the product of the leading diagonals minus product of opposite diagonals. So 10 will multiply 2. 10, you have 10 multiplying 2 minus negative 3 multiplying 12. So when you simplify this, you then get 56. Yeah. So let's move on to this one. This one is determinant of A1. Now let's move on to determinant of A2. The determinant of A2 is the product of the leading diagonals minus product of opposite diagonals. So we have 1 multiplying this 12 minus 10 multiplying this 3. So determinant A2 will give us -18. Yeah. So after doing this, then we find our x1 and x2 in this way. So x1 will be equal to the determinant of a1 over the determinant of a. Then x2 will be equal to the determinant of a2 over the determinant of a. So what is the determinant of a1? The determinant of a1 is 56. And what is the determinant of a? So did we find the determinant of a? Let's go ahead to find the determinant of a. So let's take a. You have to find the determinant of a. So determinant of a will be equal to the product of the leading diagonals, which is 1 multiplying 2 minus the product of opposite diagonals, which is -3 multiplying 3. So 2 will multiply 1 and be 2 minus -3 multiplying 3 will be -9. So it will become 2 minus -9. 2 minus -9, this one becomes 11 because positive and negative will become positive. Hence, determinant of a is 11. So we put 11 over here. Let's move on to x2. So x2 will be determinant of a2 over determinant of a. Well, we found the determinant of a2, which is -18 over determinant of a. You just found out that the determinant of a is 11. Yeah. So over here, our x1 is equal to 56 over 11, and our x2 is equal to -18 over 11. So this is the result of solving this linear equation with Cramer's rule.